Hello everybody, and welcome to the video on Chapter 1 for Calculus 1. So if we were meeting in class for these 2 days that we're missing, day 1 we would talk about the syllabus. That would take half an hour or something, I don't know. And then for the rest of that class we would talk about pre-calculus and what you are expected to know for the class. So we're missing 2 days of class. We're actually only doing 1 day of class through these videos, okay? So before I meet with you on Monday and we start doing some actual calculus, I want to make clear what pre-calculus you are expected to know going into the calculus material. Okay, so in this video I'm just going to cover sections 1.1 through 1.5. That's an entire chapter of the book. So I'm not going to cover that material. I'm just going to highlight for you what you should know, or what should sort of be at least somewhere in your brain before you take a calculus class. So Chapter 1 is a review of pre-calculus, and here's the outline of what you're expected to know. The first section is just all about functions. What is a function? What's the graph of a function? How could you represent a function? Dependent, independent variables, things like this. Section 1.2 says, okay, you know what a function is. There are several that you just need to know really well, okay? There are all sorts of wacky functions out there in the wild, you know. Which functions do you need to know because you come across them so often? 1.3 is about graph transformations. How do you take a graph and move it around or stretch it or whatever? Section 1.4 is about exponentials, and section 1.5 finally is about logs. So that sort of sum total there is what you're expected to know going into this class. Now maybe you don't have to know all of that intimately. Maybe it doesn't have to be at your fingertips, but it does need to be in your brain somewhere, ready to be brought forth if need be. Okay, so let's start with section 1.1 and functions. So again, I'm not going to cover all this material. I'm not going to explain all of it to you. I'm just going to show you what you're expected to know so that if you have questions about, say, gaps in your knowledge, you can identify them now, and we can try to fix them now, okay? So usually a function is given by an equation or by a graph. So here's an equation example, right? F of x equals whatever. So here x is the independent variable, and you input values into the function by substituting for x. So what does f of 2 mean? That means you are inputting a 2 into the function. So therefore that 2 replaces the x in this equation. So 2 squared minus 3 times 2 plus 4. You end up with an answer of 2 out of that. If you input a 0 into the function, well, input a 0 into the function, 0 squared minus 3 times 0 plus a 4 is 4. Okay, so when you input a 2, the output is 2. When you input a 0, the output is 4, right? That's how a function works, input, output. You input a number, the function does whatever it is supposed to do. In this case, this function squares things, then subtracts 3 times that thing off, then adds 4. So you input something, the function does what it's supposed to do with that input, and you get an output. Okay, here's a graph of a function. So looking at this graph, you should be able to make observations like, if I input a -4, I get an output of a 1. If I input a 0, I get an output of 5. Input a 2, get an output of 5. If I input a -2, I get an output of 3, and so on, right? This graph also represents input-output information, right? Points on this graph represent an input followed by an output. So a picture like this is conveying the same kind of information as an equation like this. You can recognize or dig out input and output relations. What else should you know about functions? You should know the terms domain and range, right? The domain is the set of inputs or the set of x values, the set of things you can put into the function, sorry, typo here, into the function and not break anything, right? So the set of things you input so that you're not dividing by 0. You're not taking square roots of negative things, etc. You should know the range is the set of outputs. These are the set of y values that the function hits. And you should be able to read off either of these from a graph. Okay, so this is something you would have spent a lot of time doing in a pre-calculus course. You should be able to deal with piecewise functions. So if you get what that means, here's a piecewise function. A piecewise function has different function formulas for different parts of the domain. So here, if x is less than 3, you use this 2x minus 6 formula. But if x is bigger than 3, you use the 5 minus x squared formula. So you should know, for example, that f of 0 is negative 6 because if I input a 0, 0 is less than 3, therefore I use this formula here, this 2x minus 6. So you should be able to compute values like that. You should be able to draw graphs of these things. You should be able to draw this guy's graph, okay? You should know that it's this line to the left of x equals 3 and this parabola to the right of x equals 3. You should be able to visualize that in your head and then draw it. You should know the terms increasing and decreasing. So increasing is just a fancy way of saying going up, and decreasing is a fancy way of saying going down. So in this graph here, from x equals negative 4 to x equals 0, the graph goes up. So on that interval, the interval from negative 4 to 0, this graph or this function is increasing. From 2 to 4, from x equals 2 to x equals 4, this graph is going down, so it's decreasing. And then on this little stretch here where it's flat, it's neither increasing nor decreasing. Right? So you're either increasing, decreasing, or staying constant. Okay. That's the end of section 1.1, right? That's just like a global overview of what functions are and some vocabulary. In section 1.2, your book gives you a list of important functions, functions that come up over and over and over again, right? In a pre-calculus class, in a calculus class. Linear functions, you should know these. You should recognize them as such. You should be able to graph them. You should know what they look like, you know. Quadratic functions with an x squared in them, right? Again, you should feel comfortable with these dudes. You should be able to graph them. You should have a good feel for them, right? Polynomials, so functions where there's no cap on the squared number. So quadratic means the highest power is 2. With a polynomial, you could have an x to the 100, x to the 2 billion, whatever. So this is going in sort of a, increasing nesting or something. So linears are really specific functions, as are quadratics. Both these two kinds of functions are examples of polynomials, okay? So polynomials are a really broad class of functions. It includes the linears and the quadratics. Rational functions. Rational functions are simply polynomial divided by polynomial. Okay, so polynomials don't involve fractions of x, right? No fraction there, right? Rational functions can involve fractions with x's in them. Okay, this number 5 is key, trigonometric functions. So what I'm saying to you with this number 5 is you should know trig, you know. You should know what sine x looks like. You should know what cos x looks like, tan x. You should be able to tell me what sine of 0 is. You should be able to tell me what cosine of pi over 4 is, etc., right? So there's a lot packed into this item 5. This item 5 is saying you need to have seen trigonometry and know it, you know. Exponential functions, things like 2 to the x, 3 to the x, 4 to the x, e to the x. Functions like that, you need to know what they look like. Like you should be able to graph them, or at least sketch them. And finally, you should know about logs. Right, so there's a natural log function. You should know what like log base 10 of x looks like and how to compute log values. So section 1.2 just goes over all of these and points them out. Now, I should say that if some of this is unfamiliar to you, you should crack open the book and read about, say, logs. Like, remind yourself how logs work, right? So again, in this video, I'm not telling you how logs work. I'm telling you need to know that, right? I'm giving an overview of what you should know going into this course. So if we were meeting in person, I would try to gauge your level of comfort in person, right? I might give you a survey or something, like ask you on a scale of 1 to 5, how comfortable are you with each of these kinds of functions, you know? But we're not meeting in person for this. Section 1.3 is all about graph transformations. So what does that mean? You start with some basic graph you're familiar with. What does it mean to shift it up or down, shift left or right? How do you reflect across an axis? How do you stretch a function? or a graph. So for example, the way this comes up in Calc 1, and this comes up a lot, especially towards the end, you guys know what this looks like. This f of x equals x squared. You know what that guy's graph looks like, or at least you're supposed to. Given your knowledge of that guy's graph, you should be able to picture in your head what 4 minus x squared looks like. Okay, why is that? Well, first of all, cover up the 4 for a second. Pretend that 4 is not there. Negative x squared, what does that mean? That means you have taken the original graph and reflected across the x-axis. You've used the x-axis as a mirror. So this used to be a smiling parabola, starting at the origin and going up. This negative x squared is a frowning parabola. It starts at the origin and frowns down. And then you just add 4 to that, right? There's like a plus 4 right there. So you take that frown and you move it up 4 units. Like you should be able to see that happening in your head. Exponential functions. You should be able to graph something like e to the x, sketch it, and its basic transformation. So you should be able to tell me that like e to the x minus 3, right? What does that look like? Well, you should be able to graph e to the x and then shift it down 3 units. You should also be able to solve basic exponential equations such as this guy here. Okay, so again, this is something you would have done in a pre-calculus class a lot, especially this equation solving thing. So here you just have to take natural log of both sides. You would have done that a lot in a pre-calculus class. Finally, you should be comfortable with logarithms. You should know what natural log of x looks like, what its graph looks like, and you should therefore be able to do basic graph transformations. You should be able to handle basic logarithmic equations like this. Okay, so basically what am I saying to you? I'm saying somewhere in your brain should be like all of high school math before calculus, except for like geometry, you know? Like you got to know trig, you got to know the algebra, right? You got to be able to handle functions, and especially the famous ones, right? Okay, now in conclusion here, when I see you in class on Monday, recall that I'm giving you a quiz over these videos just to check that you've watched them. So if I were you, before Monday, I would do the following. Okay, first of all, if you're not comfortable with some of the stuff in here, you say to yourself, man, I don't remember what cosine looks like or whatever. You should crack open the book and remind yourself. And if you have issues, you let me know. Okay, as soon as possible, you let me know. Like if you think that you're just not comfortable with trig or you just can't remember how logs work or whatever, let me know. We'll sort it out next week, that week that I'm back. For the sake of a quiz, though, I'm not going to quiz you over random pre-calculus questions. I just want to make sure you watch this video. So I might ask you something like this. Tell me 1 or 2 kinds of functions I said you have to know. So you could say, oh, you said trig and you said linear, or whatever, right? Or I could say, true or false? Do you have to understand piecewise functions in this class? You know? And you say true, right? Did I talk about piecewise functions in that video? Yes, you did, right? Do you have to know domain and range? Yes, I do. Whatever, right? That kind of question, right? So again, this quiz I'm giving you that covers this video plus the syllabus is not hard, okay? Not supposed to be hard. And you can take handwritten notes on this if you would like and then use them, okay? I just want you to have watched this, thought about what you know and what you don't know, right? Think now. Do I remember how graph transformations work and whatever? And after having done that thought, please let me know if you are worried about something. Okay, see you on Monday.